Professor Gnanasegaran, sir. I wholeheartedly welcome you, sir. Sir, your motivation, encouragement for conducting this kind of webinar series, really, it is very honor and for us. I wholeheartedly welcome you, sir. Today, the resource person, Dr. Karthik, is a senior scientist, Center for Solar Energy Materials, International Advanced Research Center for Powder Metallurgy and New Materials. It's an autonomous research and development center of Department of Science and Technology, Government of India from Hyderabad. I wholeheartedly welcome you, sir. Definitely, your provoking thought process will help us in translating our quality research in terms of technology. Definitely, it will be useful for our faculty members, sir. I wholeheartedly welcome you for this session, sir. I also welcome our IQAC coordinator, Mrs. Suguna, for taking this initiative for conducting this kind of webinar series for our institution. I welcome you, madam. So apart from this, I wholeheartedly welcome all the IQAC coordinators and faculty members of Vinayaga Missions Research Foundation deemed to be university for this 34th quality webinar series on quality translational research, technology development, demonstration, and transfer. I once again welcome you all for this webinar. Thank you. Thank you very much.
Thank you, sir. To provide direction and to have the courage to go first and create a better tomorrow for one's follower. Now I invite Professor Dr. P. Gnanasegaran, sir, Director of Internal Quality Assurance Cell of Vinayaga Missions Research Foundation, deemed to be University, Salem, to share a keynote address for today's webinar. I hand it over to you, sir.
Thank you, Priya. A warm morning to all of you. It's indeed a great pleasure to be before you on this 34th webinar of the Quality Webinar Series organized by IQAC of VMRFDU, and this 34th webinar is being hosted by IQAC of VMKV Arts and Science College, Salem. I congratulate the principal and the IQAC coordinator of Warrior Arts and Science College for hosting this webinar. And I'm really, looking back, I wonder, we are completing nearly 3 years of this webinar. We started this like during the COVID to keep all our IQAC coordinators in touch with each other, though we were separated apart by the pandemic. And technology helped us, and we thought, why not continue so that this will be a knowledge sharing platform for all the faculty of the university. So this has been going, and we do hope it will continue in the future. Coming to the today's webinar, we pretty well know research is one component which is inbuilt in any university system. Being a deemed university, again, we are bound to do research, and again, being a multidisciplinary university, we do have more responsibility in translating multidisciplinary research using our multidisciplinary approach. And today's topic is rightly chosen, and it will really benefit all our faculty. We are in the third cycle of our NAC assessment, and all pretty well know that research carries more weightage in NAC assessment, and likely that we will be scoring good marks in research, looking at the way research is being taken up in the university, the support being given by the management for research, and how it is being translated into technology, and how technology transfer happens with more startups coming up in the institutions. We at the university have 3 incubators, one in each of the engineering colleges approved by MSME, and one is another Section 18 company at Chennai campus. All these three incubators have incubated close to 26 startups in the recent past, and nearly dozen technology transfers have happened, and it's still on. So I'm really happy that this topic has come out today, and the speaker also. I'm really happy to note from a renowned agency and a person with a long history of research. And it is right to know the right things from the right person. So I take this opportunity to invite Dr. Mani for this webinar, and we do hope all the participants will take home wonderful message to translate their ideas into development and technology transfer. I once again wish all the participants a wonderful webinar, and thank you, one and all.
Thank you, sir. Now I invite our principal, sir, to introduce today's resource person.
Okay. So today's resource person for this webinar series is Dr. Karthik. Hails from our Tiruchengodu, near to our institutions. And rightly, he is working as senior scientist in Center for Solar Energy Materials, International Advanced Research Center for Powder Metallurgy and New Materials. It is an autonomous R&D center for Center of DST, Government of India, from Hyderabad. He has published about 67 research publication in highly referred international journals. He has filed about 11 patents, 4 of them were granted. Apart from this, he has participated in the international national conferences workshop as chairperson, as invited lecture. About 74 invited lectures he has given. So apart from this, he has worked at different organizations located in South Korea, Taiwan, Italy, and Spain. He has received several research fellowships from the University of Torino, Italy, and NSC, National Science Council, National Chaotang University, Taiwan, and KAIST, South Korea, UGC, India, DAE, BRNS, India. Most importantly, our Indian embassy in South Korea selected him as one of the best Indian scientists for scientific interaction with our late Honorable Dr. APJ Abdul Kalam, former President of India, during his president visit at Seoul, South Korea. He has received an award Best Scientist in Supercapacitor in the year of 2019, which is awarded by RULA and which is powered by World Research Council and United Medical Council. His research area of specialization includes material science, nanotechnology, porous carbon materials, photocatalysis, fine chemical synthesis, air quality management, and pollution control, solar energy harvesting, thermal energy conversion and storage, batteries, and supercapacitors. His papers are frequently cited and also appeared in the cover page of journal. He has also served as guest editor for many journals. He has also delivered several invited talks in the national, international webinars. So with this small introduction, I wholeheartedly welcome Dr. Karthik for this 34th quality series on quality translational research, technology development, demonstration, and transfer. I welcome you, sir.
Thank you. So may I start, Dr. Anbalagan? Hello.
Yes, sir.
Yes, sir. Yes, sir. You can proceed.
Yeah. Thank you. So first of all, very good morning to all, and my heart welcome to all the participants in this webinar series. I think it's very until you mentioned the 34th of the series, and first of all, I would like to thank Dr. Anbalagan to invite me in this series to deliver the talk. And actually, we are already more than 15 years, almost 10 years, 15 years back, we worked in Taiwan when he was a postdoctoral researcher. I am also as a postdoctoral researcher and associate professor there. And so this is, I'm basically, my hometown is Trichangodu. So it's very near. I would like to visit this Vinayaga mission. I am always going through the Salem to Trichangodu on the way through the Vinayaga mission. So anyway, next time I will like to visit and no.
Definitely, sir. You are most welcome.
Thank you. And also, thanks for your nice introductions about my careers. And thanks to the director of IQAC and the coordinator of the organizer. So today topic, as he well said, the need of ours and the need of our country, the translation research, it means the translation research, the technology development, demonstration, and transfer. Is it full screen?
Yes, sir.
So Anbulahan contact me actually since this is my first talk regarding the translation research, how we technology development, demonstration, and transfer. Anbulahan suddenly, maybe 2 weeks before, called me, sir, please deliver the talk on the technology development, demonstration, transfer. Just I am asking him, within 1 hour, is it possible to cover all technology development, demonstration, transfer? Like that, first I asked. Actually, it is India, there is several institutions there. My main focus on what generally RCA is doing and how the translation research happening and technology development, demonstration and transfer. So as he already explained, ARCA is the Autonomous Institute of Science and Technology, Department of Science and Technology. It's almost 25 years over. You know that DSA started 1971. 2021 is already celebrated 50 years. So International Advanced Research Center for Powder Metallurgy New Materials is almost 20 years is across. This is our entrance of the institute. I think the people are not well known about our RCA. Just I explained about them. This is located in Hyderabad. You can see here. Now it is in Telangana state. Actually, this area called near to airport. I think almost 20 kilometers from International Rajiv Gandhi International Airport from in Hyderabad. So this area is called Balapur. So here, all the DRDO institutions, Dr. Abdul Kalam also worked here. So it's almost more than 15 to 17 DRDO, DMRL, or RCA, ARCA, all are located in this area. So this is completely, we can tell, science and technology and a whole hot research going on this area. So in ARCA, what is our main motto is the technology development, technology demonstration, technology transfer. That is a today topic also is highlighted in this direction. But ARCA is focusing on surface engineering. We have different disciplines: surface engineering, ceramics, laser processing, alternative energy, nanomaterials, and automotive energy materials. I think you know that all the topics now, energy is booming in India. So a lot of people are working in, for example, EV, electrical vehicles, to develop on the batteries. And on the other hand, now the another sector is hydrogen generation. So hydrogen is the future fuels, high energy density fuels. So now the government and as well as the other institutions, private entity, for example, HPCL or the Reliance, all the petrochemical industry, they want to make the hydrogens. So now the another area interest alternative energy is the hydrogens. So surface engineering, generally ARCA, we are collaborating with the DRDO, ISRO, other entities. So we are working on the providers of solutions, and you can see here, the main motivation is demonstration, technology development, demonstration, and transfer. So development of high performance material and process to niche market, demonstration of technology at prototype and pilot scale level, and transfer of technology to the Indian industry. So you can see the thrust area of ARCA is the different sectors. I already explained that: power, alternative energy, pictures and electronics, water and textiles, so on. So ARC already developed 41 technology, developed 41 technology and transferred to the Indian industry. And more than 200 technical solution provided. We already provide, because we not only technology, suppose some industry, they have some problem. For example, ISRO or DRDO or some components they want to develop. They approach in ARCA because ARCA have the expertise in, you can see the coatings, ceramic coatings, fuels, nanomaterials, engineering coatings. So we provide the solutions for the existing problem for example, DRDO, any industries or ISRO. so on. So this is our main activities what we are doing in RCA. So if you see technology concern, for example, we are the success in the textiles, self-cleaning textiles. So in this case, nano silver, TiO2 micro uncoated on the fabrics. That fabric is the technology transfer to the resins. That's why you can see here our director is receiving the award from the ex-presidents of India. And this is silica aerosol flexible sheets for, I am giving just one few examples. The silica aerosol flexible sheet for thermal insulations. And we are also developing recently, we developed the indigenous battery material in ERCA, the technology transfer to some Indian company. And also we are working in supercapacitor and the ceramics things. As I said, several industry, they have some problems in they are contacting ours. So we are providing solutions. We are developing some ceramic materials, high energy material, and statistic applications. So you can see the already ARCA having 125 patent already filed, more than 1,000 publications, and 330 technology leads on transfer, and 1,500 research and technical manpower trained. So this is our overall activities in ARCA and achievements. So actually, I am a material scientist. I have been worked in Center for Nanomaterials as well as the Center for Solar Energy Materials. So in this case, what we are focusing on, for example, the solar cells, photovoltaic, the renewable energy. I think you know that now India is focusing on renewable energy because generally, if you have the fossil fuels and non-renewable energy having the pollution problem and the health hazards. That's the reason India is focusing on the renewable energy generation. So in this one of the renewable energy, that solar, in the solar concern, concentrated solar power and the solar PV, that's called photovoltaic to convert the solar radiations by photovoltaic techniques to convert the electricity. That is called perovskite solar cells and silicon perovskite tandem. These are all we are actively working in develop the materials wise and develop the prototypes. And this is the major area in the Center for Solar Energy Materials. I am plans to that. Then functional coating. You know that solar panel having a lot of problem. So in this case, what we are developing in our center, because Saktiver is our team leader, he is a scientist and a team leader. So he developed the solution for example, solar panel. Solar panel lifetime is more than 25 to 30 years. But what is the problem? India is we have a lot of dust. We have pollution problem. So once if your solar panel is covered by the dust or deposition or the pollution, whatever the dust deposition in the panel, so your performance panel degrade. So in this case, we have the different groups. It's called a functional coating. So easy to clean and anti-siling, anti-reflecting, dual functional coating. So in this case, what is easy to clean? It's like you see the lotus effect. If you put the water on the lotus leaf, what happens? It's super hydrophobic nature. The water is repelled from the lotus that leaf. The same phenomena here. What our Dr. says, Dr. Saktival sir and other the groups they are developed that shine super hydrophobic coating on the surface of the panel. That is only to reflect the the dust, and also we have multiple coating. So it's a reflect the dust as well as that whatever the dust is not deposited, and also once if you for only simple water, the dust is saved. So in this case, we can the performance of the solar panel is not degraded. So in this work we are also doing. And solar thermal, that solar thermal is very important, energetic field. So because when I was in Spain, we are working with concentrated solar thermal power plants. So from this is one kind of renewable energy. So we can collect the sun if sun is free of cost. So from the sun radiations, we collect using some technology that solar energy is converted into storage, thermal energy storage. From the thermal energy storage, we can run the turbine to generate the electricity. That is well known. For example, in Spain, I have been working more than 5 years in this technology. So we like to work the same technology here, but also we are working for the technology development for this kind of phase change material for medium temperature, low temperature, medium temperature, high temperature. For example, medium temperature, high temperature, there is a lot of industry, they are having the waste heat. So in this, we are developing some kind of the phase change material oriented technology that will capture the waste energy generating waste heat generated from the, for example, steel industry, cement industry, glass industry. So we capture this the waste heat, then we can convert into the useful heat or process heat, or the waste heat can be recovered and reused. So the enormous energy we can store, and also we can it is very waste instead of waste, the waste to wealth concept. So renewable energy storage, that's what we are working on. For example, India very problem is we should use the the very India is a very hot country. So problem we are also using air conditioning. So in this case, how to avoid this air conditioning? This air conditioning can be provided by the solar thermal. So in this, it's called energy efficient building. Then thermal management of batteries and other electronics. So these are the major area we are working on. So this today topics, the technology translation research, because as I explained that our RCA's main innovation is technology, the translation research, technology development, technology demonstration, technology transfer. That's why our main motivation. So in this case, so in this center, to Satyavale and our groups, what we are working and what are the technology we develop and transfer to the Indian industry. For example, solar receiver tubes for low and medium temperature solar thermal application. As I said, so solar thermal is there is a two type of solar thermal is non-concentrated and concentrated. For example, non-concentrated people know that the solar water heater. So in this case, all the tubes are developed from China. There is no indigenous tube developed in India. You know that China is the one of the major hub for the international market. From following slides, I will explain. But if there is no development, indigenous development in India, the cost of the product is very high. That's a major problem. So that's the reason if you have own technology, indigenous technology within India, then your product is substantially, the product cost is substantially reduced. Because if you buy the products from the abroad, China or our neighboring country, we need to pay the tax, the foreign tax. Suppose if your products developed within India, the indigenous development and easy, the transportation is very easy. You can, if suppose if any modification, you can very easily modify because your factory is here within country. So these are the several advantages there, product within India. But if you develop the product within India, what is the major problem is you should be cost competitive. This any products if you develop, there is three important factors are there. One is the product cost. What is the cost of the product? Cost. And your performance. So the performance is on board with the already commercially existing products or not. Then durability. So any products, if you buy, this is the three factors is very important consideration. One is cost, another one is performance, another one is durability. So in these three factors, we should consider from the starting itself, we need to develop products. That products only going to be a technology, development and transfer to the industry. Because Indian industry should involve in this to you buy or acquire your technology. Your technology should be a cost effective compared than the existing system. So that is our major focus. We are working on developing the, not only this developing the tubes, we are actually improving the performance of the tubes and cost effective. This is already the transfer the technology to the Indian company. This another one, as I explained, the technology to anti-soiling, easy to clean coating. For example, photovoltaic and other applications. This also technology transfer to the Indian company for the photovoltaic company. They already purchased and they take the technology from RCA. And also this anti-soil, easy to clean coating as well as the anti-reflective coating. There is a company called Borosil. I think Borosil, the glass manufacturing company. It is located in Gujarat. They are also buying the glass, PV glasses. So per day they are making more than 10,000 glasses. So they are having some. They are mostly what are the technology currently they are using from China technology. So first point they are purchased the ARC technology, that is the coated on the PV glass in order to enhance the anti-reflecting of the coating as well as the dust repelling coating. So in this case, the performance of the every PV panel is increased. That's the reason they already purchased the technology from us. And the another hand, this is where another technology is the high temperature stable spinel nanocomposite absorber coating. As I explained that if you see the concentrated solar power, there is two technologies there. Non-concentrated and concentrated. Non-concentrated means the temperature less than 100 degree that is suitable for water heater. Suppose if the temperature more than 100 degree, for example, 100 to we can go for 500 degree, the different type of application we can focus. But in this go for, I mean, the 100 to 500 degree high temperatures, your product should be stable, as I said, cost effective, high performance, and it should be highly stable in the corrosion environment, what are the application you are looking for. That's the reason we are developing the spinel-based monocomposite absorber coatings. And the band reflecting, anti-reflecting coating, this is already based on the Borosil. I already explained that the Borosil is one of the leaders, glass manufacturers in India. So they already acquired this our technology. They are using in commercial in plants. Then we have the functional coatings, for example, nanofluids, heat transfer fluids. This technology, actually the HPCL, that Hindustan Petroleum Chemical Limited, they are also developing the heat transfer fluid because heat transfer fluid using for different applications. For example, in the transformer, you need to circulate the oil and in order to cool the transformer, and also the heat transfer fluid used for the several reactors to cooling purpose. In this case, the heat transfer fluid could be high thermal properties. Then only you can effectively utilize the heat and to recover the heat to cooling the system. That's also we are developing. So this is one example, as I said, explained. Another example, as we are also working on the batteries and supercapacitor. So in this case, battery and supercapacitor, India is now the booming sectors because most of the electric vehicles are now planned. And as per the, that Indian, the government, DSC also make the program as called FAME, the fast adaptation manufacturing of vehicles in India. In this program, we need to develop our indigenous, for example, lithium-ion batteries as well as supercapacitor. So in this case, for example, I am giving supercapacitor because since I am working in last 5 years in supercapacitor. So anything, if you want to develop the technology, but you should know first what is the market penetration in global as well as Indian standard. So Indian supercapacitor market, what is the projected to grow? For example, because some of the articles they are the expectation. So these what are the application point of view? For example, consumer electronics, transportation, renewable energy. So these are the first we need to make the survey. So these products internationally and nationally, what is the market penetration? What is the market value? So how to develop? So we should know that first that scenario. Then only we need to focus on what we need to develop within countries. So, for example, the supercapacitor concept. Supercapacitor, which is there is lot of capacitor manufactured in the world. The leader is Maxwell. It is US-based company. So in this case, what they are doing, process. For example, they are doing coconut shell active, the coconut shell. You know that coconut shell is then that is coconut shell activated carbon. We know everyone that because coconut active in India also a lot of companies, for example, they are taking the coconut shell, then the carbonizing, then activating. That is useful for activated carbon for several applications. But in this case, the supercapacitors based on positive and negative electrodes, that is the activated carbon based. So what Maxwell is doing, that take the coconut shell, they are burn the coconut shell, it became the carbon, the charged carbon. Then there is the activation process, activated carbon. After that, the activated carbon into the powder form, then they make the electrodes, then they make the cell. So you can see the flow of this. So actually the raw material, then activated carbon, then it comes to the, like this. You can see the charcoal after the activated carbon. This activated carbon, then there is a process to make it shell, and finally we can get the device. So in this case, this device, what are the applications? For example, the device manufactured itself, whether this device is having energy density or power density, as I explained already, durability, cost. So depends on your material grade and performance and application should be classified. For example, Maxwell is making device, but the carbon is well-known company in Japan is called Kurare. So Kurare manufacturing the activated carbon, that activated carbon well-tuned because I don't want to in depth in technical details, well-tuned. All the activated carbon not suitable for supercapacitor. So we need to well-tune particular properties, then only that material suitable for supercapacitor applications in with respect of high performance and durability concern. For example, we developed this material in our RCI. So what we did, the commercially available carbon, and we tune these, we prepare the composites carbon. You can see the composite carbon. You can see that this is the YP50, that is a Kurare carbon Maxwell is using currently. So our carbon, you can see the very high performance. Not only this, you can see the cell durability, and durability is very important. So how many cycles? 15,000 cycles we are testing the materials as well as our material. Then what is the durability? And also then you need to work for the physical characteristics of material. So every material, the well-tuned property is very important for the commercialization. For example, what are the key features? It should be cost effective. It should be scalable process, very easily scalable process. Any industry come and approach you, the first thing they will ask, sir, it's a cost effective, it's a scalable, and it's a how many lifetime durability. So these three important parameters very important. And apart from that, if you compare for the commercial standards, because your technology somebody acquire, it should be your technology should be better than the commercial available. Otherwise, at least equal to the commercial available. For example, if you see some foreign, for example, YP50 carbon, they are developing in Japan. So we need to buy the carbon from Japan. Suppose we develop our own indigenous technology within India, it's very easy. Transportation easy, your cost is, because the indigenous development cost is reduced, then easy to get it without any foreign tax. Also, these are the beneficial for the indigenous development of the carbon within India. For that, technology status. So any technology, if we are telling we can write very nice papers, we can write patents, but we should have technology transfer means we should have the patent right, that is IPR, intellectual property right. Then we need to file the patent. If, for example, in this case, we file the patent, and commercial size, we need to prepare the, I mean, not only material. For example, some people, they are interested in material, but some people, they want device. So I want to compare the device with on par with the commercial stuff. What is the price and all. So on. So what we are doing, in this case, laboratory level, we tested a lot of, for example, our supercapacitor as well as our supercapacitor carbon as well as the commercial carbon, we made the small coupon level test in laboratory level, because any technology is not overnight development. So we need to focus on the laboratory level. What is the performance of the material? What is the performance of the device? To doing small prototype level. Once if you satisfy this level, so we need to screen the material, which is the best material to suitable for the commercial applications. In this best material, we are going for the lining. So this is actually, we have different projects, HPCL, DRC, and DST is funded, our ARC is funded by DST. So we write the projects and in the industrial collaboration. So we make the setup line. So in this case, some people, they are interested to buy your material itself, but some industry, they want the device level. So in this case, what we did, we make the device, for example, what is the supercapacitor device available in the market, the same size we made and we arrange it. Anyway, this, the processing is from carbon, then there is a, lot of processing involved in that. From that, you can get the final device. In the final device, we can charge and discharge. For example, we make the prototype systems. You can see here, these are all our indigenous development. Then we demo for the real, for example, bicycles, supercapacitor. This is the first supercapacitor bicycle in India. So we make 1,200 farads, and there's the team members we are working in different disciplines. So we arrange, for example, the BMS developed by device electronics from Pune. So there is a this is the electronics component is very important, because if technology means not only materials, it have the material engineering and electronics. The electronics means you should have the control your power capability and what are the charge and discharge capability, everything. The CMS is the capacity management system, is heart of the battery. So this only controlling the voltage, everything. So with load, without load, we real system we developed and demonstrated. Then only this is very interesting for the commercialization for the product. People are, they come forward to take the technology. So this is just examples I am giving. For example, for whatever we are using the ECD clean coating and battery and supercapacitor, what material we are working and how to them. So if you see concern the indigenous development, make in India, I think this the line figure everywhere. I think it's, our Prime Minister Narendra Modi launched the Make in India initiative. So what is Make in India really? So why Make in India? What is the meaning of Make in India? You see, Make in India means ultimate objective is to make India to renowned manufacturing hub for key sectors. So companies across the global world to be invited to make investments and set up factories and expand their facilities within India. So using India highly talented and skilled manpower to create world-class zero defect products. The purpose of Make in India campaign is job creation, economic development, global recognition. So what is the mission of the campaign is manufacture in India and sell the product worldwide. So this is the concept government of India launched this program. It's, it's early 2014. It's going to be, almost 9 years. So going to be 10 years, 1 decade. So this is a Make in India concept. The main thing is we should develop our indigenous technology development that transfer within India. That's the main motivation. So since we are from Department of Science and Technology, so DST, because the government of India says the program, so it is through some medium, that is a DST, Department of Science and Technology program boosting Make in India initiative. So you can see here from these different sectors, different mode of, the products development field of interest. So they are identified 5 different institutions within India. So that is called, the program is called Technical Research Center Program. So you can see here, every institute we got, like this is almost 5 years over. This second phase is going on, 2015 to 2020. One program. Now, then 2022 to 2025 is another program. 2 phases. This Technical Research Center program is going on. And actually, these 5 research centers, one is from Sri Chitraranal Institute of Medical Science and Technology in Trivandrum, International Advanced Research Center for Powder Metal New Material, that is ARCI, Jawaharlal Nehru Center for Advanced Scientific Research, I think JNCSR, Bangalore, Indian Association for the Cultivation of Science, ICCS in Kolkata, SN Bose National Institute of Basic Science in Kolkata. So these are the 5 identified by DST, and we are also getting every 100 crores every each institute. And what we are doing is the energy sectors. We are working because the DRC is given to ARCA. In this DRC, for example, 100 crores projects. In this, different sub projects are there. Every projects we are working, for example, batteries and supercapacitor. Then we are developing some very good motors and waste heat recovery and magnetic materials. And fuel cells, the hydrogen generation and fuel cells, and electric hybrid vehicles and solar energy. As I explained, the concentrator, solar thermal power plant, and photovoltaic. We can more details. You can see our website. These are all the major activities. What is going on DRC program? It is in our website. So this is the government is really initiating and providing a lot of programs in order to motivate to enhance the Make in India programs. For example, now we are working because I am metal scientist, as I explained, we are working on the EV, for example, batteries and supercapacitor. For any electrical vehicles, you can see how many components are required. You see here. So these all the components are at the present. We are, buying from outside of country. There is no components, very less components manufactured within India. Most of the components we are, for example, EV vehicles. EV vehicle development, these are the components, various components important to driven the vehicles. So in this case, not only battery arrangement. So we have a lot of components. So all the components, now there is no manufacturing. So we are always depends on the China. So you can see the China, how much they got CAGR, which is a compound annual growth rate, almost 30% from this year. Whatever the media is explaining, you can see China is one of the major hub for the entire world. So if you develop within country indigenous development, then only the technology will grow for our nation. So it's very easy to implement. It's a very less expensive cost. So just I am always telling joke, because we are last 2 years we are really affected by COVID. Not only we buying all the components from China, even COVID also we received from China. So this is just for joke. I am always telling the student. So you see, India, one side Department of Science and Technology, CSIR, MSME, and DSIR. So many industrial, the institution is there. They are ready to fund funding and develop the technology. Apart from this academic side, we have the Indian Institute of Technology, right? 23 IITs are there. If you see another hand, 31 NITs are there. National Institute of Technology. Both are, you please, that's a Indian Institute of Technology, National Institute of Technologies. So, if you see, this is IIT, NIT, I'm not consider any other institute, if you can see. So, if you, this institute, every year they develop one technology, India will get more than 50 technology. At least 3 years once, if you develop the technology, every 3 years we can get to 50 technology. But IIT is mostly focused, some now recently last 10 years, IIT really not only academics, but they are developing some spin-off companies, incubators, and are now developing. But that is not enough. What we are having infrastructures, we have the manpower potential. So one is academics, industry. Then there is I am not criticizing IIT, NITs because their mandate is now, even though it is technology-oriented institute, but the mandate is mostly 90% is education. We are developing a very good, brilliant manpower. That manpower within countries we need to serve. But unfortunately, IIT students are going outside. They are, that's the reason Indian our own technology is a problem. For example, if you say the one cell phone we are using, India is one of the largest cell phone user because we have the population is very high. Now almost 130 crores population is there. You imagine at least 80 crores or up to 100 crores people they can use mobile today. But in the mobile, still we have the scratch card, mobile bar, battery, everything coming from China. In the small mobile, we don't have any manufacturing in India. So where is the problem? Problem is, the next slide you can very clearly understand. One is academic, another one is industry. So academic people, they are focusing on only academic. Industry people, they purchase the technology from outside, they are developing their own and they are focusing on industry. So where is the problem? So this is the problem. So one side is, I think how many of the audience they know about the technology readiness level, the so-called TRL level. So TRL is actually the invented, discovered by NASA, 1978. Because they are, NASA different approach. But slowly this TRL level is adopted by the research entity in Europe sites. When I am working 10 years before, people are using only TRL level. If you tell the TRL level number, they know what is the maturity of the TRL level, which state. Not necessary to explain, we are developing the material, prototype, demo, not required. I am in TRL level 6. If the industry people is coming in Europe, because we are working in several industrial oriented programs when I was in Spain, in Italy. So even TRL level number itself self-explanatory, where is your level? For example, 1 to 3, the basic research to proven facilities. It means it's a laboratory. Most of the people now India, rest of the world also doing in government universities, that is a basic research. You can see here. The technology is 1 to 3. And if you see the private sectors, sorry. Hello. Sorry for this. So one side is technology. Sorry. Hello. Yeah. No. I'm talking. Hello. It's okay. I am audible.
Yes, sir. Yes, sir.
Yeah. Okay. So here one side is the government universities, because the less investment, they are focusing on only for the basic research. Another side, you should see technology level 789. It means it's a commercial entity, commercial available, commercialization. But that is private sectors. Most of the Indian technology we are purchasing from outside because there is no very less Indian technology available. So these are the major problem. Yes, I explained. We have very good institution, very good industry, but there is a huge gap that is called, valley of death. So in this, what is our focus is how to fill this indigenous low cost development. That is the mostly RCA, our mandate, we are focusing on that. For example, RCA is Autonomous Institute of Science Technology, but we have the PhD students. Our PhD research scholars, they are registered in IITs nearby. For example, in Hyderabad, we are having the IIT Hyderabad, University of Hyderabad, and NIT Warangal, NIT. Also, we have registration in Chennai, Bombay. So these students are working with the professors in IITs. They are registered IITs, but the working complete PhD program in ARC only. So they have opportunities to work with us to develop the products. And the basic, because we have time to time, every 3 months, 6 months interaction with the professors, they are giving the basic knowledge and basic improvements and science, basic science. Then that is very useful for us to develop the another side. We are also working with the industry. So industry people, they have the problems. So once the problem is identified from the industry to come discuss with us, so we have give some solutions. So we have the one hand, we are also working with the academic, another hand, we are also working with the industry. So both if you join together to only, we can have success to develop some nice technology. So that is the TRL level is classified 1 to 9. So 1 to 3 is the basics. The 4, 5, 6 means already you identified some products. I need to develop in little bit. That's why the supercapacitor, you know that we are making in first itself, we are not making in kg level. We are making in gram level. First, we check the coin cell level. Sorry, coin cell level. Then we can go for little bit 1 kg level, then 10 kg level, then 100 kg. Then only we are supplying this material to the other entity. How we are really this material is working good or not, we are evaluating. We are somehow you can get certificate also. Sorry. From that we are going for the next level for the technology development. So this is happening for the it should happen for the all the products which we develop. For the DST, this is just for the general audience. I am giving the innovation and technology development programs. There is a lot of programs. You can go and see the website. I already given the website in the bottom of the slide. The Science and Technology Entrepreneurs Development, the Technology Mission Program, Technology Development and Transfer, the Technical Research Center. Already I mentioned that Technical Research Center is five central institute identified from DST. We already got the received the funding from 2015 itself. There's now the second phase is going on. So 3 programs, Science and Heritage Research Initiative. So these are the programs. Once if you approach, you have, for example, you are from the university or the college level. First, you need to identify the products. What are the application you are doing? You need to have some proof of concept. Okay, this product is scalable. You need to approach this kind of entity. Okay, we could please give the funding for that, and you can further fund of the program into the level. It's not possible to direct go for the technology transfer. You need to first further development. After that, for example, this is everything growth by TRL level. For example, 1 to 3. Then you can move to 3 to 4, 5. When the mini prototype level, laboratory scale level, and online demonstration. For example, our photovoltaic, whatever the technology we showed, we first tested in our rooftop. We are taking all the water, everything. Then we have the, I will show one of the how to approach that next slide. So these are the programs available. So you can contact once if you small level prototype ready, then you can get the acquired funding. This is some of the programs. Also, industrial partner is involved. So you can get the sharing of the industrial partner. Then you can develop your technology. Same industry or some other industry, they can acquire your technology. Here, what are the area of core area of inviting proposal under TPD? There is a technology development program. The advanced manufacturing technology. Recently, we received one project from advanced manufacturing technology. That is, we are developing the prototype system for the industrial waste heat recovery. For that, we received the funding from advanced manufacturing technology. Here, ARCA and the VIT value, there is a partner. We have jointly proposed this proposal to submit the DST, and we got the fund. What is the VIT role? The VIT value, there is a professor in mechanical engineering. They are doing very fundamentals and what are the, for example, if you material selections, for example, SS304 stainless steel. So what is the corrosion? What are the fundamentals they are studying? So what ARCA is focused on? We are developing the reactors. That material we are going to use, whatever the VIT developed. So we have, this is exchange program. So we already received the joint projects. For example, VIT and ARCA, just I'm giving example. So waste management technology, biomedical, device development program, technology development program, DHA, that is the Department of Heavy Industry. For example, if you electrical mobility, for example, your electrical background, suppose you have discovered something new for the BMS or CMS, you can approach, for example, this kind of programs, then you can get the acquire the funding, then you can develop your technology in the future. So technology development and transfer. So here, just for definition, maybe some of the very beginners, I think, in my students also, when I am discussing, they are confused with what is the invention and innovation. What is invention and innovation? Totally different terms. Invention. For example, invention is the new material discovered. For example, TiO2. The TiO2 first discovered in Japan, that is called Fukushima and Honda. He is the father of photocatalyst. That is means the TiO2 is a semiconductor material. The first time it is act as a photocatalyst. That is people discovered. That is called invention. What is the innovation? I think one of the previous slides I showed, innovation means silver particle doped on TiO2. It is act as an antimicrobial activity. That is called innovation because you are modifying properties or addition or something new that making the different properties. That property can be useful for different applications. So that is invention. Also, they can call because you can file the patent because innovation is also converted to invention. But pure invention is first discovered. What are the new material discovered? For example, graphene. The graphene is first discovered. For example, a lot of material first discovered. For example, carbon nanotubes, TiO2 is another. And then, for example, carbon nanotube is very good heat transfer fluid because people adding carbon nanotube to some fluids increase the thermal conductivity. So that is called some invention. There is a lot of patent filed. You know that. Then patent. I think patent is very important for any technology transfer because patent giving the IPR, intellectual property right. So we should file the patent, whether Indian patent or foreign patents. So within India, you need to technology. So patent is important. Then copyright. You know, the copyright is a license. So trademark, you can have your own product name, logo, or geographical indicators. That is the trademark. So if you want this idea to conceptualization to the commercialization, for example, idea, then technology development, technology transfer, technology commercialization. So this is the huge steps. So idea to technology development, as I explained, there is a lot of entities there. We need to find, first small products, testing. That is, we should compare with on par with the commercial entity. Then we are satisfied. We identify this products work okay. I identify this product is good. Technology development. For example, small institute, universities, they don't have funding. So maybe they can approach for the industry how to commercialization, or they can approach for the DST, or that lot of institute available in India for funding agencies, for example, MNRE or MSME or DST and DSIR. So you can contact them, you can have some technology development, maybe collaboration with industry or without industry. Technology transfer, of course, you should have some incubation center or startup companies. While you can very small entrepreneur, for example, IIT graduates, now they are starting small companies. Then after that, once if they pick up the company, then there is a subsidy, MSME, there is a lot of subsidies coming. So after that, you can real technology transfer to the single company or multiple companies. Technology commercialization. This is the innovation pathway of change. So what is technology? The technology is derived from Greek word. Technology is art, skill, ability, which is used to create the development products or acquire knowledge. Scientists use the knowledge to develop technology and then use technology to develop science. So, because of the reason, science and technology are the integrated terms today's world. So, science and technology we are calling. So, science and technology, I think I don't want to hear teaching. So, science and technology, science is very fundamental, as I explained. So, science, most of the people are at academic and for example, IITs, NITs or universities, they are doing. So, fundamental knowledge is very important because it is the basic of any technology. From the fundamental knowledge, we can develop the technology for the commercialization. That is very important. That's why we need to collaborate because one person, for example, we can't develop everything. We should have something where it's the lack of us, so we can collaborate with the different entity to develop the products. So in this case, development science and technology, we have the Council of Science and Industrial Research, CSIR, the Research Development Organization, Indian Institute of Science, Indian Space Research Organization, Defense Research Development Organization, Indian Institute of Technology. The another thing, Indian Institute of National Institute of Technology, are there, and also there is a DSR. The DSR means the Department of Science, Scientific and Industrial Research. So intellectual property is very important because this is IP rights. So we need to file the patents, and from this we can have the intellectual IP or rights. So I think the patent need to file, then only we can have your rights to make the technology transfer. It may be an Indian patent. First, mostly what our preference is, we make any technology, we can make the Indian patent. That is going to be, if you're very interested in technology, then we can go for the international patents, because Indian patents very less expensive. But if you go for the international patent, we need to retain your patents, then we need to pay more. So internationally, so the government, we are from government money. So when you are using the patent internationally is very useful, then only we are making international patents. Otherwise, we can hold only Indian patents. So I'm telling everything. You see, we are developing lab. For example, ARCA, we are developing some products in the laboratory. Then we are satisfyingly we develop in technology level 3 to 4 up 5. So how the industry people know that we develop this technology in our institute, in our center. So that is publicity. We need to have the publicity of your technology to the entire world or entire country or at least entire region. So what is the purpose? What we are approaching is technology information sheet. We need to make the browser. So we have the title of this. In this technology, you see, this is a one sheet browser. We are making what is the key features? The performance analysis of the real-time performance. For example, this is a easy to clean coating for the solar panel. So performance evaluation, you can see the real panel. We are doing the online performance, then performance validation, performance analysis, and you can see, as I say, explain that what are the hydrophilic properties in the real field applications. What are the applications we are doing? What is the technology status? For example, we filed patent and what are the patent granted or what is the status of the patent? Everything. Then contact details. What are the scientists and our directors? Out of the central head. So we put the contact details. We publish this in our website. So and also we have separate center for the technology acquisition and development center. From that we have team leader and there is a group. So we need to give this one technology information to them. They will, for example, they are going for a conference or publicity, some media. So we are also having the media articles. We are publishing this to entire, from the media sources. Then only some of the people are really seeing this information sheet. They come forward to take our technology. That's happening. Most of the technologies we are, commercialization or, for example, technology transfer to the industry. So technology transfer is nothing but you can have the skill development, knowledge, technologies, methods, method of manufacturing, samples of manufacturing, and even facilities also you can make the technology transfer. So in this case, for example, we are putting our browser into the entity. Some work companies coming. So how we approach? So in this case, directly non-disclose agreement, NDA agreement. First, we have some pencils. From that, what is the ARCA role? What is the company role? First, we need to write. We need to sign the NDA. Why you are interested? Non-disclosing agreement. It means what are the intellectual property, what are the secrets, what we are doing, we should not disclose. On the other side, the company, whatever they are doing, they should not disclose. So for that, we have some stencils, non-disclosure agreement stencils. So from that, both parties signed. That is the documentation. Another know-how documentation and transfer. So know-how means how you are developing the product from laboratory to, as I explained, TRL level. For example, 2 to 3 to how you are making the product up to TRL level 6 or 7. All the documentation. For example, small scale, what is the performance? If you make the large scale, what is the performance? What is the, if you real field application, what is the, so these are, we need to document. That's called know-how documentation. And that documentation can be transferred to the industry. Then they have the, in the documentation, we have the different projects. What is the steps? The transfer of list means we have different steps we follow. For example, what is the objective that know-how documentation? What is the scope? What are the parameters? And this is several steps involved in this, For example, what is the small, as I explained, small scale prototype, upscale prototype, what is the property? And if you go upscaling, what is the property? What is the property variation? Everything we need to documentation. That's called know-how documentation. That is sent to the industry. The people, they will check whether all these parameters are given, if good or not. Then only they are interested. When we have the team, they will calculate the technology cost calculation. Every technology, even though we are a government organization, we will make the technology cost. That cost depends on the how manpower, how utility, what are the source resources we are utilized in ARCA. So depends on the cost, we transfer that cost to the industry. If they are interested, they will take our technology for real application. So in this case, technology transfer is invention, innovation, designs, and marketing. As I said, marketing means diffusion. The market penetration is very important. Already explained that invention and innovation, original concept, innovation is the development of refinement or change of any existing idea or products. So design is For example, design of the products, for example, mechanical engineering, we have some computational software. Now the artificial intelligence and machine learning is coming. So from that, people are really making the design of that products. That also you can have, better ability. And the diffusion nothing but the market penetration. So before the product development, so as a researcher, as a scientist, we should know that what is the market penetration, what is the diffusion into the market. The product is how so it's a promotion in this our Indian market. So that we need to analyze. That also when the technology transfer, the company will also ask. Anyway, that is their duty. They also take the technology. They have some market team and the market penetration is identified and there. So this is overall, as I will explain, the research and development that is mostly involved in universities and research institutes. Then production, manufacturing, distribution, the companies will involve. For example, in RCA, we can develop up to few cages. It's not possible in industrial productions. So this few cages itself, we can identify this product is suitable for the particular applications. So the company will ask this some quantity of products, we'll give this, then they will systematically test, okay, we are happy about this product. Then they can make whether they can probably they are saying to join projects to develop the technology. Otherwise, directly they purchase the technology, they will directly go to the market or manufacturing and distribution levels. So technology development, that for example, here, the trade secret is very important. What technology, what are the compositions we are using? That is, it should be unique. For example, lot of examples there. Just for example, the WD-40 is a well-known, the US brand. For example, KFC, that there is a lot of ingredients. Still, the KFC chicken is a very crispy. So this kind of some ingredients, quality of ingredients they added that. For example, Coca-Cola. Coca-Cola, still the chemical composition of Coca-Cola is not revealed. So people are still, I know this is just, so it means you should make it your identity, trade secrets and patentability. That is very important for the, for the commercialization of the product. This is just for example of the technology, Technology transfer process, as explained, invention disclosures, assessments, productions, marketing, licensing, and finally, financial returns or financial support and industrial contribution. Then we can go ahead. And as I explained that, the technology transfer in RCA, we are also following two types. One is the exclusive and non-exclusive. So technology transfer, you can go for the exclusive manner, means only single company, they are very interesting in that. Then we can go for one technology cost, we can give only particularly for the exclusive manner. Non-exclusive manner means you can sell your technology in different companies. For example, your technology's cost is 5 crores. There is a 5 companies interested. So every crore you can give 1 crore to one company, 2, 3, 4, 5. That is called non-exclusive. So exclusive means 5 crores, only one company take the 5 crores, your whole technology, you are not able to sell this technology to anybody. So the license is completely given to particular organization or particular company. Non-exclusive means not like that. You have the technology cost, maybe as I explained in the 5 crores, you can divide in multiple companies. That is non-exclusive basis. We are depends on the technology. Mostly as a government administration, we will prefer the non-exclusive pattern. So technology transfer process, there is a lot of steps involved. The technology acquisition and selection of the, I don't want to go for the very details, but in general, I do the flavor, the technology acquisition, the selection, collaboration, and finalizing the agreements, and mainly the technology acquisition and technology absorption and technology adaptations and technology improvement. So these are all the 3-4 steps the technologies can make. And also technology, what is technology improvement? For example, we are developing already technology in the tier level 6-7, but still go for the commercial level. There is some, for example, large quantity, but batch by batch, some properties sometime will vary. Small variation will be there. In this case, still continuous R&D required. For example, what is the tuning? For example, 1 kg material used in the laboratory, you can go for 10 kg or 20 kg, 1 ton. Very small property variation because of the mixing or the ingredients we are adding. So small variation will be there. That is continuous research and development still. That is called technology improvement. So technology transfer, R&D process technology, the quality assurance representative, production representative, and engineering representative, and the quality control representative. So these are the technology transfer in the industry people also working. We are also working on. So I don't know about in details. This is the quality assurance, production reproducibility, and quality control is very important because once if you, for example, and comparing our carbon with the Kurare. So what are the quality control? For example, everything reproducibility, the surface area, pore size distribution. What are the characteristics of the carbon should match with the on par with the commercial availability. That is called the quality control. So in this case, the step involved technology transfer process, development of technology R&D level, technology transfer to R&D productions, optimization productions, and technology transfer documentation. So everything we have the barriers. So what are the barriers of technology transfer? This lot of barriers are there, but as per this, the lack of awareness, knowledge, and efficiency, lack of government focus, and low market share. As I said, because every products are there, you should have the market penetration very important. For example, we are making several patents, but all the patents are not interested for the commercialization. It means that patents having no market value. So we need to assess in that market valuable products. Then only the technology interested. So web access and scientific publications, the cost of pre-qualification, national security issues, and sometimes some of the technologies are really very good for, but because of the national security issue, for example, DRDO, DMRL, they are developing very good technology. Sometimes national security is not going to be viable in the market. So inadequate funding and possible and labor issues. So the skilled labor is very important because, as I said, you need to develop your laboratory to this one, the skilled manpower and lab issues, how to, is any problem in the technology, how to solve it. So these are all the major barriers. So when you are going for the commercialization, the technology one side, and then you make the products in a n number of products, this is called generally TPM. So market consumer mode. So these are the, well known for the commercialization process. The technology commercialization, this is the triangle is very important. For example, technology donor, then technology broker and technology receivers. So these all are three interconnected, and one side is market pull and another one is a technology push. So in this case, sometime we are transfer the technology that company is not interested to develop the technology, and furthermore, your technology going to be dead. So in this case, we should always push these technology. No, this technology, what is the problem? We need to give some solutions to them. Then identify the solutions to make it technology viable. And once one technology, one company develop the technologies, it's going to be a further development in our country. Otherwise, the technology will die, then it will stop. Then stockholders is very important. First stockholder may be a technology producers or technology consumers, the product producers, the product consumer, and of course the resource provider, government agencies, intergovernment institutions, and donors, and financial sectors and technology transfer intermediates. So these are the very important for the technology commercializations in the end of this story. And yeah, I would like to stop from here. And thank you for your kind attention. So this is open for questions, any doubts, and thanks for your listening.
Thank you, sir. Yes. So now the session is open for discussion. Sir, I have one fundamental question. So you know that peoples of chemistry background will work on the nanomaterials. So we will prepare some nanomaterials. Then we will test some antimicrobial activities like antifungal or anti-inflammatory, something like that. So how is it? Which level of technology? Yeah, you told the technology TRL 1, 2, 3, 4, and so on.
What is your size of the testing?
Sample size, sir.
Sample size.
Okay, it may be 5 or up to 5 to 10 samples we will be testing for the activities.
Yeah, but no quantity.
Quantity.
Maybe how much ml, how much they are. That's why I explained.
Okay.
For example, we are developing some materials. So
Okay.
first time we are developing several materials for the laboratory level. For example, 10 materials. 10 materials not possible to screen to make next TRL level. So TRL level may itself indicate the basic level means the screening of the material according to the what are the commercial available products, for example. So in this case, I am making 10 materials. I may choose 2 or 3 materials for the identical material that is well suitable for the on par with the commercial standard. Then I can upscaling the material. For example, milligram to gram, gram to kilogram, kilogram to several grams. So that is the indicate the technology level of the increment. For example, you are microbial activities, you are testing in small cultural level or something, for example, 100 milliliter or 1 liter. So if it works means how it is suitable for other large quantity. That is very important because industry, they are not looking for small samples.
Okay.
They look for the large samples. For example, we are making the 18650 over small cell. Once, not only one cell is not going to drive your electrical motors. So we should have 48 cells. So 48 cells, we need to connect serial parallel combinations. According to, there is, I explained the CMS, capacity management system to integrate. Then only your motor will run. So that is the final products. So that's the thing. We need to collaborate and how to make this technology first for the prototype demonstration.
Okay.
Then only they upgrade to next level.
Okay.
So then all the product not possible because there is a always positive negative points are there. But what are the suitable? Then we need to work hard. What is if you have something problem, then we can collaborate with them to how to push this technology. For example, small incubator centers or small center. Then we can go for technology. Because industry directly they are investors. They are not directly come and put your money in your table. And the Indian industry, we are working in Taiwan. I have worked in South Korea. Still, worldwide, we are using LG and Samsung. Worldwide, we are using LG and Samsung. So, just I'm giving one examples. If you Korean people, they have, for example, that LG and Samsung, they have R&D. So, for example, 2 crores they have money, they identify 10 laboratory, they put every 1 crore in the industry to the 10 laboratory. After 1 year, 2 years, any one laboratory success, they will get 100 crores back.
Nice.
So this mentality, because I am approaching a lot of companies here, not in India, it will come because we are not in India. A lot of problem, but trust is very important. What develop because why they are putting, for example, case they work in case Korea Advanced and Technology. The people come and put the money in the means they have some trust. Okay, this research group, the researchers, they are developing very good electronics, what are the components and that. But out 10 lab, maybe 9 lab may be failure, but they are not considered failure. That is the learning. Maybe 1 lab is success. They can 100 crores back. So that is the some strategic money policy. So that is mentality should come in Indian point of view. That's the reason even so many laboratories, they are developing good technology, but not commercialization. That's the
Okay. So ARC is also working on hydrogen batteries.
Yeah, fuel cells. We have 2 centers. One is Hyderabad, another one is in Chennai, in IIT campus. You know that park, IIT Science
Research
Park is
park.
research park. There is the on floor. They are working in fuel cells, magnetics, and battery. They are working.
Okay. Okay. Any questions from audience? So you have shown some funding schemes by Department of Science and Technology. One, your ARC is collaborating with VIT.
Yes.
So you know that our university also received under waste management scheme of
Okay.
DST. It is a collaborative project between our arts. You know that our arts and science college and our dental institutions.
Yes. Oh, that's why. Say it's not some institute giving some seed money, but technology development, we have the DSAR is there, DST is there, but we need to approach it. I think this is the entity, I think in the audience, they may clearly understand how to approach and how to go step forward, how the technology using. But 1 hour is not possible to explain complete because this is a really wide topics. There is a lot of problem we are facing. Even very good technology, we are convincing the industry is not easy. People are very struggling because they are mostly thinking, the cost effective and it should be very easy implementation.
Yes, yes.
It's very important for the technology transfer, industry adaptations. So that is, that's we need to work hard. It's not easy to transfer single technology in the Indian market. We should work very hard, and it takes several years for the. I will show you a lot of technologies developed. It's not overnight. It's almost 10 years period we worked and we transfer the technology. Now it's coming up.
Yes, sir. I think it is very dry area for being an academician, technology transfer, so that there are very low number of queries or doubts
Yeah.
for our faculty members.
Yes, yes, yes. No, it's not. It's little bit. Even IITs in NITs are very good funded because they are IITs professors very good knowledge. Even though they are still because mostly academic oriented. But if you see CSAR also working, but not that much effective in India. I mean, should good motivated and should go ahead.
Okay. So if there are no questions, sir. No, sir.
Yeah, go ahead.
Okay. Priyadashini.
Thank you, sir, for your valuable time spending with us despite of his busy schedule. Be thankful what we have. You will end up with having more. Now I invite Mrs. M. Suguna, Associate Professor and IQAC Co-Coordinator of Vinayaga Missions, Kribananda Variyar Arts and Science College, Salem, to deliver a vote of thanks.
Very good afternoon to all. It seems to be a great honor to propose the vote of thanks to all who have helped us making this webinar series a very resounding success. First of all, I would like to propose my hearty thanks to our chief guest of the today, Dr. Mani Karthik, Center for Solar Energy Materials, International Advanced Research Center for Powder, Metallurgy and New Materials, Department of Science and Technology, Government of India, Telangana, for raising today's webinar. Thank you, sir, for your thought-provoking, interesting address. I would like to express our deep gratitude to our IPAC coordinator for his presence of guidance. I am happy to express special thanks to our principal, Dr. V. Anbalagan, VMKV Arts and Science College, for his moral support and dedication. A special thanks to all the participants from the various colleges. So finally, I thank our beloved colleagues and non-teaching faculty members. Last but not least, our wonderful technical team support. Once again, thanks for making this event a grand success for us. Thank you, sir.
It's been a pleasure being with all of you today. Thank you for your patience and active participation. Thank you once again. Thank you all.
Thank you.
Thank you, sir.
Thank you.
So,
Thank you, sir.
ஊருக்கு வரும்போது
சாரோட கோஆர்டினேட்ஸ் டைரக்டர் ரிசர்ச் கொஞ்சம் ஷேர் பண்ணுங்க.
பண்ணிடுறேங்க சார், உடனே பண்ணிடுறேன்.
ஓகே.
அவர் நெக்ஸ்ட் டைம் ஊருக்கு வரும்போது நம்ம இன்வைட் பண்ணுவோம் சார், கண்டிப்பா வரும்.
Yeah, sure.
Yeah, definitely.
Please do drop in, sir.
Yeah, yes. Thank you.
Thank you.
Thanks for your support. Thanks for arranging this wonderful talk. Just I want to share our what we are doing and our thoughts.
Yes.
Thank you.
Okay. Yeah. Thank you very much.
Thank you, sir.
Thank you, Dr. Anbalagan. Yeah.
Thank you, sir. Thank you.
Yeah. Okay. Fine.
Thank you, sir.
Thank you, sir.